Hello everyone, and welcome to the series of NTA NET December 2019 expected questions for computer science and applications. Now, last examination, that is in June examination, we have launched exactly the same series. So these videos that we are publishing here, this is exactly the same videos that we have published in the last session. Now, because students requested us, sir, please publish these videos earlier than the schedule, and they requested us that they wanted these videos and they like this series, so that is why I'm publishing these videos again. I hope that you will like this series, and this series will be very useful for you. Now, if you like these videos, now to support us you can do two things. Number one, you can like the video, just place a like, and secondly, please comment below. So actually YouTube helps the videos which get maximum engagement through likes and comments. So if you really like our videos, if you really like this series, please like and comment under the video. That will be very beneficial for us, and it will help us to grow more and more, and it will help us to post more videos like this. Now, before moving ahead, this is just a very quick announcement for the students who are preparing for NTA NET examination. So whether you're preparing for NTA NET December examination, or whether you're preparing for next year NTA NET June 2020 or December 2020 examination. So right now, because of Diwali festival, we have a huge discount that is going on for our courses. We have various courses, like we have a 3 months preparation course for NTA NET, we have 6 months course, and we have 1 year course, which is having both pre-recorded videos and live sessions. So there are various courses that is present on our website. So if you really like our courses, if you like our videos, it's better that if you want to have a complete lecture series, complete proper comprehensive video materials for NTA NET, please go and check out the courses on our website, or you can just WhatsApp us and call us on this given number, which is 9821876104. So again, as I said, if you want to support us, please like the video, comment under the video, and subscribe to the channel. And don't forget to visit our website, which is www.dgmentor.com.
So we have our first question, which says the subset of super key is a candidate key under what condition? Okay, so the first option says no proper subset is a super key, all subsets are super key, subset is a super key, and each subset is a super key. So quite confusing, so no need to get confused. So just read the question carefully. Okay, they're saying the subset of super key is a candidate key under what condition? Okay, what is the relation between a super key and a candidate key? A super key is a superset of our candidate key. Okay, they can be equal or not. This will let's say if my super key is ABC, if let's say my attribute A is satisfying all the properties for being a candidate key, then A alone can be our candidate key. Okay, so they're saying the subset of super key is a candidate key under what condition? Only one condition fulfills here, that no proper subset is a super key. They should not be equal, then only, because they are talking about the subset. Okay, the subset of a set cannot be the same set. Also, a candidate key is a set from the super key, which cannot be the whole of the superset. Okay, that's why it is a proper subset of the it should be the proper subset of our super key. Okay, so only option A matches. All these three options saying the same thing, and which is wrong. So be careful, and the answer is A here. So we have our next question, which says which product is returned in a join query have no join condition? So basically they are saying, let's say if I have a table, let's say A, and with attribute A, and let's say it has attribute 1 and 2, and let's say I have this table 1 and this is my table 2. Table 1 has attribute A, and table 2, let's say, has two attributes B and C, let's say X, Y, A and B. Okay, now they are talking about when there is no join condition between these two, then which of the product is done? It is actually Cartesian product. So what we do is, when there are no join conditions, we do Cartesian product. Okay, equijoins and outer joins, they both are joined on the basis of some condition, so we will apply Cartesian product. So how Cartesian product for T cross T2 will look like? A, B, C, let's say A, X, Y, and 1, A, B. Each element will be multiplied to all. Okay, so 2xy and 2ab. Okay, so this is how Cartesian product is done. This kind of question is also been asked for the natural join also. When there are two tables and they do not have the same name attributes, then how they will be joined? They will be joined using the Cartesian product. Okay, so B is the right answer here. So we have our next question, which says in DML, reconnect command cannot be used with optional set, fixed set, mandatory set, or all of the above. Okay, so in DML, data manipulation language, we know that we have few commands and we use them. So we use different modes for that. Okay, so the most important modes that we use is retention mode. Okay, now the retention mode determines how the record occurrence can be removed from a set occurrence with the DML statement, like erase, disconnect, or reconnect. Okay, now if this reconnection mode is fixed, then the record occurrence cannot be removed. Okay, or all other functions like reconnect or connect, they cannot be removed unless the record is erased. So if the retention is fixed, then we cannot use the reconnect command with it. So clearly B option is right here. A, C is wrong. Mandatory set is different thing and optional set is different thing. They are used for different purposes, different modes in DML. Only B is the right answer here. So we have our next question, which says which one of the following is a set of one or more attributes taken collectively to uniquely identify a record? Is it candidate key, sub key, super key, or foreign key? Okay, so we know foreign key is definitely not an answer because it is used in different tables to refer the data. Okay, sub key is totally different thing. Now the answer is now narrowed down to candidate key or the super key. Okay, so there is always confusion between these two options, but look at the question very carefully. They are saying which one of the following is a set of one or more attributes taken collectively to uniquely identify a record. They are talking about we are taking one or can take more attributes to uniquely identify a record. Both candidate key and super key, they both uniquely identify a record, but it is a super key which adds more and more attribute in it, and then it forms a unique record. For the answer would be candidate key if they would have asked about the minimal key to uniquely identify the record. These are a few keywords which you need to remember. When they talk about the minimal, then the answer should be candidate key, but they are saying one or more attributes taken collectively to uniquely identify a record, so that's why only super key is the answer here. Don't get confused. Okay, so we have our next question, which says which one of the following is false. So we have to pick out the false statement here. Okay, so it is about the normalizations. Okay, so the first statement says a relation in BCNF is always in 3NF. This is right. Okay, BCNF, Backus normal form, is stricter than the third normal form. First we have one normal form, then we have two normal form, and then we have third normal form, and then we have Backus normal form. Okay, so BCNF is the most strict one. If something is in BCNF, it will be in 3NF, 2NF, and 1NF as well. If some table is in 2NF, then it will be in 1NF and 2NF. Okay, but not in 3NF. May or may not be in 3NF. Okay, so the first statement is right. A relation in BCNF is always in 3NF. After clearing all the properties of 3NF, then only it can be a BCNF. Okay, and this is more stricter version of 3NF. So the next statement says a relation in 3NF is always in BCNF. This is not necessarily true. A relation which is in 3NF may or may not be in BCNF. Okay, so this is the option here because we have to pick out the false one. C option says every binary relation is always in BCNF. What is BCNF? BCNF says only a super key can give the key, non-key. What it says is it should be the super key, and this should be non-key. Okay, only a super key or a candidate key can derive a non-key attribute. Okay, And they're talking about the binary relation. It means here only A is giving B, let's say, and this one is my candidate key already, then this is already in BCNF. Okay, so C is also right here. Now the fourth option says the relation R is in one first normal form, as a relational database does not allow multi-valued or composite attribute. This is also right. The very first condition which every database must follow, that there should not be any composite or multi-valued attribute. Okay, so B is answer here. So we have our next question, which says a B tree used as an index for a large database table has 4 levels including the root node. Okay, so basically they are for the indexing they are using the B tree method. Now if a new key is inserted in this index, then the maximum number of nodes that could be newly created in the processes are. Okay, this is a very easy question. I just have to imagine. Now they are saying that the technique is B tree. Okay, and we know at each level there are fixed nodes that we can save, and how we calculate them using the order. Okay, they are saying there are 4 levels. So let's say this is level 1 and there are few data, and this is my level 2, and let's say this is my level 3 and I have few data, and then this is my level 4. There is many data, indexes and everything. Okay, so let's say I want to we will be talking about the worst case, because they are saying the maximum number of nodes that could be newly created. So we are actually talking about the worst condition. What we do is, in the B tree, when a node is trying to insert in a already recorded index table, then what can happen is, if there is no space for that, then it can split. Okay, so now let's say I have some data and I'm trying to insert it in the last node, but it is already full. So what will happen? It will be overflow. So what it will do? It will split up. Okay, so a new node will be created. Now the data which will be splitted will come to its parent node. Then let's say it is also full. Let's just assume all these are full and I'm trying to insert a new node on all the full. So what will happen? It will split up. So let's say I am inserting this into this one, so it will split up. Now the data which will come out of it will enter into this level. Okay, let's say it will again split up because it was full and one new data is coming here, so it will also split. Now after splitting up, this data, the split data, will come here, and again this will split. This data will move here, and this full node will also again comes under the overflow category, and this will also split, and one of the node will come at the top. So how many new nodes are created? 1 2 3 4 5. So in worst case we can create 5 nodes. How? Because let's say there were already 4 nodes, okay, and we are trying to insert a new node, and we will imagine the worst condition that they are already full. So what will happen when I try to insert in a fully node? It will split. Then again the data from which will come from here will come here, and then again overflow, split, will come here and then split and then come here, and then the last data will come out and it will form a new level here. So that's why 5. So we have to just imagine the worst condition here. So we have our next question, which says which product is returned in a join query have no join condition. So basically they are saying, let's say if I have a table, let's say A, and with attribute A, and let's say it has attribute 1 and 2, and let's say I have this table 1 and this is my table 2. Table 1 has attribute A, and table 2, let's say, has 2 attributes B and C, let's say X, Y, A and B. Okay, now they are talking about when there is no join condition between these two, then which of the product is done? It is actually Cartesian product. So what we do is, when there are no join conditions, we do Cartesian product. Okay, equijoins and outer joins, they both are joined on the basis of some condition, so we will apply Cartesian product. So how Cartesian product for T cross T2 will look like? A B C, let's say A X Y and 1 A B. each element will be multiplied to all. Okay, so 2xy and 2ab. Okay, so this is how Cartesian product is done. This kind of question is also been asked for the natural join also, when there are two tables and they do not have the same name attributes, then how they will be joined? They will be joined using the Cartesian product. Okay, so B is the right answer here. So we have our next question, which says the maximum number of super keys for the relation schema are E, F, G, H with E as the key is. So we have to tell how many super keys can be found when E is already given as our candidate key, is the key here. Okay, so this question can be solved with many ways. Okay, so one of the ways is by solving it manually, or I will also give you the direct formula for this. Okay, so they are saying E is our key. Okay, so let's make, so this E, if this is the key, then it should be in all the super keys. All right, then only it will be a super key. So let's say one of the super key is just E. Okay, now let's say next super key is our EF. We will make all the combinations with the E. Okay, EF, let's say next one is EG, and now EH, now EFG, let's say EGH and EHF. So how many? 1, 2, 3, 4, 5, 6, 7, and one is EFGH, all combined. So we are getting 8 answer here. So this is the right answer here. So you can solve it by this. They are saying that E is the key. So this E should be in all the combinations. Okay, so this is the only way how we can solve this. Now the next way is when maximum number of possible, this is the direct formula that you can use, maximum number of possible super key with n attributes, and this is given by 2 to the power n minus 1 here. Okay, so n is how many attributes we have? 1, 2, 3, 4, so it's 2 power 3, so it's 8. Again, 8 is the answer here. So you can solve it by this way or this way, whichever way you are comfortable. So we have our next question. This is a very good question. They have given us a instance of a relation, and they are saying which of the following FDs is satisfied by the relation. Okay, so in these kind of question, what you have to do is you just try to see that if, like say, if A derives B, then the values of all the A and the B should be unique. Okay, let's say if it is saying 1 1, then if the corresponding value is 2, then for 1 again the corresponding value should be 2. It should not happen like A and B. Let's say for value 1 1, one time it is giving 2 and one time it is giving 4, then it is wrong. For the same values, they must image to the same values in the next relation. Okay, this is how we can solve this question in very easy way. So they are saying which of the following FDs is satisfied by the relation. So let's look at the first relation now. This one is combined, so let's look, this one is easier to solve, just one relation. So let's see if it is satisfying or not. So Z is deriving Y. So do Z have any duplicacies? Yes, 4 4 and 6 6. So for the 4, it is deriving two different values. Sometime it is deriving 8 and now it is deriving 4. So this cannot be hold. This is how I have explained you. Okay, you can always do this way. This is the one of the best way to do. Now let's look at the B option. Y is deriving Z. Do Y have any duplicacy? No. This one should not have any duplicacy. This side, this should not have any duplicacy, and if they have any duplicacy, then same values should be derived here. Okay, so Y, do Y have any duplicacy? No. So automatically this one is right here. Now let's check the YZ. YZ is any pair, all the pairs are unique. 8 4, 10 6, 14 6 and 4 4. Yes, all pairs are unique. So B is the right option here. If all the pairs are unique, then they uniquely identify in a relation. But if there is duplicacy, then we just have to check. If there is duplicacy, then they must derive same values, not different values. Okay, so B is right here. Now let's look at the C option. Let's first do this. So let's come to the x deriving z. Do x have any duplicacies? Yes, in 3 places. And are they deriving same values for these 3? No, it is deriving 4 here and 6 here. So C is wrong here. Now let's look at the D. Y is deriving x. Y is deriving x. Do y have any duplicacy? No. So this one is satisfied. Now let's look at the xz. Do xz combined have any duplicacy? 2, 4, 2, 6, 2, 6. Yes, they have duplicacy here. 2, 6, 2, 6. So let's see. They are saying xz combined giving y. So do they have same values in y for these? For 2, 6, 2, 6. No, one way it is giving 10 and for that it is giving 14. So this is also not satisfied. So this is clearly wrong. So only B option is right here. So this is the best way to solve these kind of question, okay? So we have our next question, which says consider the following schedule for transactions T1, T2 and T3, and they have given us the way how the transactions are occurring. So which one of the schedules below is correct serialization of the above? Okay, so the best way to solve this kind of question is we will just see what is the kind of data when there is read, there is no conflict. There is no conflict, we have no issue. But if there is read, write read or write, then we have to be careful. Okay, so these are the cases when we have to look whether the properties are satisfied or not. So they are saying what is the correct serialization. So what we do is we look at the transactions and we will see how we can manage them so that the transactions will run without any problem. Okay, so like if say look at this option, if they are saying that T1 will should occur first, then T3 and T2. If T1 will execute first, then there will be no problem, no deadlock and no problem. Okay, so this is how we have to check how they should be serialized. Okay, so let's see. So first let's catch this T1. They are saying read x, so it is performing read operation on x. So so the data here is x. So let's look at the T2. Is T1 and T2 can conflict each other? Here the data is y, so they cannot conflict. Here the write is performed on data y, so not in problem. But here the read, this read is not a problem, but this read and write is a problem. Okay, so how can we resolve it? We can resolve it if T1 will execute first and then T2. So this is how I can solve this problem. Okay, because if T1 will occur first, then it will release the data x, and then T2 can execute, and there will be no read write problem. Okay, these 3 problems we have to see. Now let's look what is the relation between T1 and T3. Now it is reading the data y, then no problem, but it is writing on x. Yes, it is a problem. So T1 must also occur before then T3. So T1 and T3 also has same relation here. Okay, so T1 is done here. Now let's look at the T2. And it is only performing on x, so let's move on. Now T2 is saying I'm reading data on y, reading, so not an issue. Read not a problem, and reading y, it is writing on x, so not a problem. Now it is now next transaction which is happening is read on y. Now T3 is reading. Is there any problem on reading on y? Yes, there is a problem, because after read there is a write on T2. So what it says is T3 must occur before then T2, because T2 and T3 has conflicting relation of read write problem. So T3 must come and then T2. So first T1 should occur, then T3 should occur, and then T2 should occur. Then that is the only way. Okay, so read and write. So this is how we will see that there are no conflicting schedules. Okay, and there is no cycle. See, there is no cycle. They are cancelling out each other. So the pattern is T1, T3, T1, T3 and then T2. So option A is right here. So we have our next question, which says consider a B plus tree in which the maximum number of keys in a node is 5. Then what is the number of keys in any non-root node? Okay, so this question is very straightforward. In this we calculate the order, and how it is calculated, it is the maximum number of child. They are saying the maximum number of keys in a node is 5, so it will be order plus maximum keys plus 1, so order will be 6 here. Okay, so why we calculated this order, I'll show you. What is the minimum number of keys in any non-root node? Okay, so keys in any non-root node is given by minimum children in non-root node minus 1, and the minimum children in non-root node is given by this formula, order by 2 upper bound. So we have order 6 here, so it is equals to 3. Okay, so we will put our value this here. So the keys, the answer we will get here, minimum child in non-root node is 3 minus 1, so it is 2 here. So option B matches here. So we have our next question, which says a file is organized so that the ordering of the data record is same as or close to the ordering of data entries in some index. Then that index is called dense, sparse, clustered or unclustered. Okay, so we know why we have done indexing. It is like the index pages of your book. When you want to search for a particular topic or a chapter, you can directly look at the index and then you can directly jump to that particular topic. It is one of the advantages. Okay, so classification, in the classification of indexing, we have read that these are of two types. One is dense indexing and the other one is sparse indexing. As the name suggests, in the dense indexing, if index entry is created for every search key value, then it is dense indexing. Okay, and for sparse, if the index entry is created for only some records, then it is sparse. Okay, so they are talking about the ordering of data and all these things, but these are the basic classification of index. All other types, when they talk about the types of indexing, then we have basically two types. One is single level index, and the other one is multi-level index. Okay, in single level index we have primary index. I have explained you more, but it's okay, you can remember these. And then we have clustering index, and then we have secondary index. In multi-level index we have basically B tree and B plus tree. Okay, so dense and sparse cannot be answered here. They are talking about the type of the indexing. Okay, these are the classification. These primary, like I'm saying, single level index or multi-level index, in these parts also this can be dense or sparse, dense or sparse. It totally depend on the implementation. Okay, so clearly these are not the answers. Now they are saying a file is, now let me just tell you how these are different from one another. Okay, so in primary index we order our data on the basis of primary key, and they must be ordered. Our data records should be ordered. In clustering, it can be non-key, but the data record should be ordered. Data records, which they are talking about here. Ordering of the data record is same as that the close of the ordering of data indexing in same in some index. So it is the clustering here, not uncluster is nothing here. So they are talking about this. In secondary it can be non-key and unordered. So these are different classification. You can read in detail about these. Okay, so answer here is clustered. You just have to pay attention to the key points that they have sent. Ordering of the data records. If they would have talked about the maintaining the key also, then it would be primary index. So these are there are few minor differences between these. Okay, so read the question very carefully. So C is the answer here. So we have our next question, which says consider three transactions T1, T1 and T2 having 2, 3 and 4 operations respectively. Then find the number of non-serial schedules. They are talking about the non-serial schedules. Okay, so there can be serial schedules and non-serial schedules. Okay, so I'm giving you direct formula. You can solve all these type of question using that formula only. Okay, so possible schedules, whether it is serial schedules or non-serial schedules combined. Actually, I'm giving you both, then we will deduct the serial one. The serial schedules can be given by using n factorial, where n is the number of transactions here. Okay, so here how many transactions are happening? 3 transactions, so it will be 3 factorial, which is equals to 6. Okay, now let's this is 6 here. Now let's see non-serial. For non-serial, first we will have calculate the formula for the possible schedules. So that is given by n plus m plus, let's say, r factorial. If there would have been 2 transactions, then only n and m will be used with the same formula, divided by n factorial, m factorial and r factorial. Okay, these are the total possible schedules, not non-serial. We will calculate the total possible schedules, then we will deduct the serial, and then we will get the non-serial schedules possible. Okay, so n and m, so these are the number of operations performed by the particular transactions. So the first one is performing 2, second one is performing 3, and third one is performing 4, divided by 2 whole factorial, 3 factorial and 4 factorial. So it is 4, 3, 7, 9 factorial upon 2 factorial, 3 factorial and 4 factorial. Okay, so it will be 1260. Okay, so we have got this one total possible schedules as 1260, out of which the serial schedules are n factorial, means number of transactions, so it is 6, plus non-serial schedules. So the non-serial schedules will be 1260 minus 6, so it will be 1254. Okay, so B is the right answer here. You can solve these kind of question using this formula. If they would have asked for the 2 transaction, then the formula will be n plus m whole factorial upon n factorial m factorial, and they are asking about the non-serial. That's why we have to deduct the serial schedules, and serial schedule is given by the n factorial, where n is the number of transactions given. Okay, so we have our next question, which says which type of DBMS provides support for maintaining several versions of the same entity? It is RDBMS, hierarchical, OODBMS, or network. Okay, so relational database management system, it clearly do not support this using the entities, same entities in different versions. So it is not the answer, not the hierarchical and nor the network. It is the OODBMS. Okay, so in this what happens is information is represented in the form of objects, as they are used in the object oriented programming. Okay, in this what happens is it allows the object oriented programmers to develop the product, store them as an object, and replicate or modify the existing object to make the new objects within the OODBMS. Okay, so basically we are using our objects like we have used in our programming languages. We use them, we reuse them, we apply some modifications and replicate them and do as number of operations we want to do. And the difference, we can say the versions, we can use the different versions of the same entity in the form of objects again and again. So C is the answer here. So we have our next question, which says which of the following contains complete record of all the activity that affected the contents of a database during a certain period of time. What they're talking about is, suppose I have done few transaction, or I have changed a few things in my database, then how can I what is the technology through which I record all the activity that has affected my database and for the particular period of time. So by the wording also, by only seeing the wording, you can understand that this is the problem of transactions, where for a smaller period of time our database can get changed. Okay, and they are talking about maintaining that log, and obviously A is the answer here, transaction log. We do maintain the transaction logs. These transaction logs are also very useful to recover from failure or when there are rollback queries. Okay, it is not query language, report writer, or data manipulation language. These are different things. They're talking about the transaction logs. Okay, as the name suggests here, transaction logs are actually very useful, and they have many applications. You can read about them. One of them is that they recover from the failures, and when I perform any rollback operations, then that time also transaction log is used. There's so many information that you can store in a transaction log, like what were the values of the data before and after the transactions, and what are the resources that have been used, what is the summary of the account information, and all this information they are maintained in the transaction log, the duration and everything. So A is clearly the answer here. So we have our next question from the SQL. So in there saying consider the following database, and they have given us two tables. In one table is works, in which their attributes are employee name, company name, and salary, and the other table is company. In this the attribute names are company name and city, and these are the candidate keys. Okay, so they are saying which of the following SQL query is used to find the company that has the highest number of employees. Highest highlighted attributes are primary keys. So these are my primary keys. Okay, so they are talking about we have to pick out one of the SQL query which is used to find the company that has the highest number of employees. Okay, so whenever these kind of questions are asked, the best thing is you make the table. Okay, in example table you can make anything, and on the basis of that you just apply these queries on that table and check whether your answer is matching with that or not. Okay, so let's say I am making here table works. Okay, why am I making only just for works, not for company? I'll tell you. Okay, so let's say I am making my table. There are three attributes I have. The first one is employee name. In short, I'm writing EMP name. The second one is company name, so CP name, and the third column is salary. Okay, let's fill out some values in it. So let's say first employee name is Jyoti, and the company name, let's say it's SAP, and the salary that Jyoti is getting, it is 90K. The second one, let's say it's Asia, and the company name, let's say it's again SAP, and the salary she is getting is 95K. Let's say there's next employee named Joey, and it is working in Infi with the salary 55K. And let's say the fourth employee named Ross, working in, let's say, IBM with salary 80K. Okay, now they are talking about the company that has the highest number of employees. Okay, so why am I using only this table? You will find out. Now let's read out the first query. They are saying select company name from company. Okay, group by company name having count distinct employee name. Now here is the catch. They are categorizing on the basis of the employee name here, which is in the table works, not in table company. They are not even joining them or giving any referential integrity that company name is referring to company name in table works, but they are using them all together. Okay, you cannot do this. You have to join two tables, then only you can apply the queries together. Okay, if you have got this, very good. Now the point is, we are using only works table. The reason is we have to choose the company name which has the maximum number of employees. If you will look at this table company, there is no way I can find out the details of my employee, like how many employees are working for a particular company. Here only company name is given and the city name is given. There are no details about the employees. Okay, so I cannot only work on my company table. I need to use the works table, and if you can see, I need to have only company name only. So that's why I don't need this company table at all. Okay, I need employee names to check whether they are distinct employees, means not two employees are having the working in the same company. Okay, and the second one is company name. I need company name to categorize in which company that particular person is working. Okay, and the third one is salary. Okay, we don't even need the salary, we just need the employee name and the company name. Okay, so that's why I'm making only table for works, not for the company, because we are going to categorize the company name and we are going to use the employee name for that, because we are going to find the company that has the highest number of employees. Okay, so let's rule out the options. Let's see. Okay, I hope you get the point. Now the first one says select company name from company. So this is the reason. In the very first step, A is wrong, because they are using group by company name having count distinct employee name. They are using both the tables without using any join query. Even again, the same thing is that we don't even need company table at all. So that's why first option is wrong. Okay, the first option is matching with the C option. I'll do it one by one. Okay, but first let's come to B option. The B option says select company name from works. Okay, group by company name. Group by company name having count distinct employee name greater than all. Select count distinct employee name from works group by company name. So it is related queries. Okay, so what we will do, I will first run the inner query and then we will run the outer query. Okay, so let's run the inner query first. It is saying select count distinct employee names from works group by company name. So first let's group the companies. So the first group is company is, I need to write only company names. Okay, so I will write the SAP. Okay, and in the SAP how many employees are there, and their name should be distinct. Okay, so two people with distinct name. The other one is Infi with one employee, and the other one is IBM with one employee. So this is the output of my inner query. Select count distinct employee name from works group by company name. First I categorize them into groups and then count the number of distinct employee names. So these two in same, this is in one and this is in one. So this is the output of my query. Okay, so let's work in the outer query. It is saying select company name from works group by company name having count distinct employee name. So this is also doing the same thing. 2 1 1. Okay, SAP, Infi and IBM. So they are saying this is my outer query and they are saying this outer query should be greater than the inner query. So this is wrong. Why? This just small mistake here. I am making a correlated query. Okay, I am relating my table with itself and then I am saying the maximum value should be greater than the maximum value. It is like saying I have my table with the maximum value as 7 and it should be greater than 7. This is wrong, right? I have made the table. I have put the output of my
outer query, it is 211, and we are saying it should be greater than the inner query, which is 211. There is no way we can ever get this. Okay, so this is wrong. It should be greater than or equal to. Okay, then only we will get this as the answer. Okay, so let's read out the option number C. This is exactly same, the only difference is equals to here. Okay, here the equal to was missing, that's why it was wrong. Here the equal to is given. Now let's look. They're saying select company name from works group by company. I have grouped them on the basis of company name. Having count distinct employee name should be greater than equals to. So first I will pick 2. It should be greater than and equal to this whole. This is my inner query. Okay, don't get confused, and this is my outer query. Now in the outer query I'm picking just this one. It is greater than and equal to, should be greater than all of them. All greater than and equal to all of them. So 2 is greater than or equal to all of them. It is equal to 2 and greater than also. SAP is the answer here. Infi, it is smaller than SAP, so it is wrong. IBM is smaller than SAP, so it is wrong. So what is my answer here? SAP. And what is the right query here? C is the right answer. In the D option, what was the from works from the okay, now let's read out. So C is the answer here. Let's read out why D is not the answer. Select company name from works group by company name having count distinct employee name. It should be greater than equal to all. Select count distinct employee name from works group by employee name. They are saying we are grouping on the basis of employee name. It is totally stupid. How can we group? I mean, with practice you will be very comfortable with the queries. You will see sometimes they give totally irrelevant query. Now let's see what they are saying. They are saying select count distinct employee names from works group by employee name. If I'll group by employee name, then my first group will be Jyoti with value 1. Then I'll have Sia with group 1. Then I'll have Joey with group 1. And then I will have Ross with group 1. And I have written the count. Next they are saying group by the company name. Company name was 2 on SAP. So it should be greater than and equal to all of them. None will be the answer. So this is wrong query because they are grouping on the basis of employee name, whereas they should be grouped on the basis of the company name because we are talking about the which of the company. Okay, with practice you will get these kind of questions very easily. So C is the right answer here. You can solve this question 2-3 times, then you will get the point. And second thing is, always take an example table, put any value you want to, and then apply queries on it and see which one is the right answer. Okay, and also one more thing, always see whenever there are more tables, always see whether they are joined properly or not. If they are not joined, then see which of the table you need to use for your query. Okay, so we have our next question, which says which of the following is not ensured by asset properties of transactions. So we all know the asset property of the transaction. A is atomicity, C is consistency, I is isolation, and D is durability. Okay, so they are saying which of the following is not ensured by the asset property of the iteration of the transactions. Okay, so the first option says the consistency of the data is preserved. Yes, this is right. Consistency means, let's say if I have transaction A and B, A in the beginning has 200 rupees and the B also. Let's say A wants to transfer B 100 rupees. Okay, so here 100 will be deducted, and how much money will now A will have? 100 rupees. Okay, and B will get 100 rupees, so it will get 300 by the end. Okay, so the total sum is 400, and the earlier also it was 400. Okay, so this shows the consistency. thing. Okay, so they are saying asset property ensures that the database consistency should be preserved. So A option is right here. B option says either all operation of a transaction are reflected on the database or none. Yes, this is also right. It is talking about the atomicity property of the of the transaction. Atomicity says where if a transaction is fully successful, then okay, and if it is in the middle get corrupted, then totally abort the process. So it is either all or none property. So B is also right. Now C says each transaction is aware of other transactions executing concurrently with it. So this is the option which is wrong, because the isolation property of the asset says we, even though there are many transactions going on, but we must not feel like there are other transactions. Okay, so that is why it is called the isolation. You should feel like you're the only one performing in the database. So the C option violates it, even it is saying just opposite of isolation. So it is the wrong option, and it is the answer because it is not ensuring the asset property. Now D says the changes made to the database after the completion of a transaction should persist even if there are system failures. They're talking about the durability. Okay, this is the definition of durability, so we have to pick out the wrong one. So C is the answer here. So we have our next question from transactions. So they have given us 3 transactions, and they have shown some some operations and how, in which order they are performing. Okay, so they are saying assume that timestamp of T0 is lesser than timestamp of T1 and then lesser than the timestamp of T2. It basically means that we are given some timestamps and T2 has the lowest one. It means T0 will be performed first, then T1 and then T2. Let's say it has the timestamp as 21 and it's this one has 27 and this one has 33. Then first 21 will be performed because it has a lower ticket, then T1 and then the 33. So T0, T1 and then T2. So we have to show, they have given us few options. It says it is allowed under basic timestamp ordering protocol but not under two-phase locking protocol. Second one says it is allowed under both the basic timestamp ordering protocol and two-phase locking protocol. C option says it's allowed under two-phase locking protocol but not basic timestamp ordering protocol. Or D option says it is neither, both of them. Okay, so basically they are talking about the two protocols. The first one is timestamp ordering protocol, and second they are talking about the two-phase locking protocol. Okay, so let's read about these two and then you can easily answer this particular question. Okay, in timestamp ordering protocol, what happens is we give the timestamp to our transactions and then on the basis of that they give their order. Okay, let's say here if T0 has lower timestamp protocol, then first T0 will perform its operations, then only T1 and then T2, and then again if T0 wants to come, then when it will get its turn. Okay, now let's say at this time it will get 36 and then this one will get 39, then again T0 can come, okay, without any problem. So in timestamp what happens is we will give the timestamp to our transaction and on the basis of that they will get some ordering and they can execute. Okay, now the second one is two-phase locking protocol, in which there is growing phase and shrinking phase. In growing phase, what it says is if you are going to acquire lock, then you acquire all the locks and then you cannot release them until you release all of them. What I want to say is, let's say T1 is getting few locks, it wants to get some locks, then it should get all the locks it wants for its transaction. Okay, but if once T0 release any one lock, then it must release all its locks. Okay, and then once it release the locks, it cannot get the locks again. Okay, so this is the basic two-phase locking protocol. There are growing and shrinking phase. In the growing phase you acquire all the locks, and in shrinking phase you start losing the locks, and once you lose them you cannot again get them. Okay, so let's see our question. So if you can see in this, what is happening, it is perfectly timestamp ordering protocol. Why? Because they have given us, they have unique timestamp, no problem in that. So first T0 will execute, then T1, and then T2, and then again T1, T0, and then T1. So it is perfectly timestamp protocol. Now why is it a two-phase locking protocol or not? It is not. Why? Because in this, what is happening is T0 get the lock on data A. Perfect. Then okay, fine. Then what it does is it release the lock. Then only, how do we know that it release the lock? Because it is the exclusive lock on write data. When T0 will release, then only T1 can get the lock. Okay, so assume T0 release the lock. Now T0 cannot acquire lock again. Okay, but here what is happening, T0 is again trying to acquire the lock, which is not possible under the two-phase locking protocol. Once T0 released it, it cannot get. If this statement would have been present here and this one would have been here, then it would be perfectly in the timestamp and two-phase locking. But here what is happening, T0 already released its lock, but after some time it is trying to acquire the lock, and same is the case with the T1. So that's why it is timestamp following the timestamp ordering protocol, but not two-phase locking protocol. So I guess it is first, it is allowed under the basic timestamp ordering but not under two-phase locking protocol. So A is the answer here. So we have our next question, in which they are saying which of the following statement is true on any relation R. Okay, so they have given us 4 statements, so we have to pick out the option, true option, which is possible on any relation, means on any table R. Okay, so they are saying R can always be decomposed into 3NF and BCNF decompositions, which are lossless, but not always into dependency preserving 3NF decomposition. The next option says R can always be, so what here basically they are talking about the 3NF and BCNF and whether they are lossless and dependency preserving. Okay, so here you need to remember only 2 points. So the first point is that lossless decomposition must always be there. Okay, it is our primary goal. Our decompositions must be lossless. Okay, it is our primary goal. It must always be followed. Okay, now dependency preserving. This is our secondary goal. If it is saved, then okay. If it is not, then not an issue. Okay, so this is the first point which I wanted to tell. Second point is BCNF is more stricter than the 3 normal form. Okay, and in 3NF there is FD preserving also, but due to the very strict behavior, sometime only, okay, not always, there might be some cases where we might not be able to save the dependencies in the relation. Okay, so these are the only 2 points which needs to be clear. Okay, the first one is there must always be lossless decomposition. If it is lossy, then we must not decompose our table. And the second one is BCNF normal form is sometime not dependency preserving. Okay, so let's rule out the options one by one. So the first option says R can always be decomposed into 3NF and BCNF decompositions, which are lossless but not always into dependency preserving 3NF decomposition. They are saying that 3NF is not necessarily FD preserving, but we have just seen it is the BCNF which is not dependency preserving sometime. So A is the wrong option here. Second says R can always be decomposed into 3NF and BCNF decompositions, which are dependency preserving but not always in lossless BCNF decomposition. It is clearly wrong. I have just told you that decompositions must be lossless. This is our primary goal. Okay, so the B option is clearly wrong. C option says R can always be decomposed into 3NF and BCNF decompositions, which are dependency preserving but not always, again the same issue, lossless. So it must always be lossless decomposition. So C is also wrong here. So D option says R can always be decomposed into 3NF and BCNF decompositions, which are lossless but not always into dependency preserving in BCNF decomposition. So D is the right answer here. Okay, so D is the answer here. We have our next question, which says consider the following statements about the different set comparisons operations in SQL. Okay, so first option statement is given as P, in which they are saying in SQL sum is identical to in operator but not sum. This is the symbol for not. Okay, in SQL, but not sum is not equivalent to not in operator. Okay, Q statement says the keyword any is equivalent to the keyword sum in SQL, and the CR statement says in SQL the keyword all is not equivalent to the keyword in, but not all is identical to not in. So which of the following statements are true? So we have to pick out the true statement out of all. Okay, so the very first point is, always remember any is equivalent to sum and it is equivalent to in. Always remember this. Okay, in any what happens is, if they basically they are used with the subqueries, in any what happens is, even if I get even a single answer, then it will get the output. Okay, so basically here only one value can be compared at a time in any sum and in the cases. So in any only one value, we are talking about just any one value. For sum it means there are some values. Okay, in what happens is, in basically when I say DNO in, let's say I am saying that DNO means department number can be 1, 2, 3, 4 and 5. So basically in what happens is, we give a set of values. Okay, so you just need to remember this. So any means, if I say that my DNO is any in these, so it will be true. For sum also it will be true. For in, it is giving set of values, so that's why it is also true. Okay, so the first option says in SQL sum is identical to in. Yes, true, sum is identical to in, but not sum is not equivalent to not in operator. Now how is it? Now let's say for sum, here for my sum the value I'm getting is, let's say 1, 2, 3. Okay, when I'm saying not sum means not 1, 2, 3, so the answer will be 4 and 5. If I'm saying not sum is 1, 2, 3, not sum means not values which are not some values, so I can send 4, 5. It is not equivalent to not in. But when I say this is my in operator, so not in, so all the values which are not in this, so all the values which are except in this. So if there are values 1, 2, 3, 4, 5, 6, 7, the answer for not in will be 6, 7. I hope you get the point. Here basically what is happening is, sum is, let's say 1, 2, 3 in this set, and so the not sum, so the values which are not in sum, it will be 4 and 5 obviously. In is like a set of values, so in I has, let's say values 1, 2, 3, 4, 5, so not in operator means all the values which are not in this, so all the values other than this, so 6 and 7, these are not equivalent, so that's why P is right. Okay, second statement is the keyword any is equivalent to keyword sum. So I have just shown you, so Q is also right here. So let's read the third one. In SQL keyword all is not equivalent to the keyword in. Yes, absolutely right. In we talk about a set, while in all, when we say, when in my sub related query, when I say it should be greater than equals to all, then it means all my query should match with all the values here. Okay, but not all is identical to not in. So basically not all means, when I say not all, when I define my not all, it means all the queries should combine must not give any answer. So that will be all the values except other than my queries. So that's why the answer will be 6 and 7 here, and obviously the answer is matching with this one. Okay, so you might be little bit confused, but actually you have to imagine this way. Any sum and in this, what happens is they all are equivalent. Any and sum work in the very same way, while in what we do is we have set of values. When I say when I have my value in, so I talk about set. When I say not in, so all the values which are not in this one. When I say all the values, then it means all the values 1 2 3 4 5 6 7. When I say not all, so I basically reject the values which are getting through my output in this sub-related query. So all the values which are except my query, so it will be 6 and 7, which is equivalent to this one. Okay, so I hope you get the answer. So we have our next question. In this they are saying consider a relation R, and they have given us attributes MNO, PQ, RST with the following set of dependencies. They are saying next consider the following set of decompositions for the relation schema R. So they have given us D1 and D2, and they have shown us how the tables are divided. So they are saying which of the following decompositions have lossless join property. Okay, so there it should be lossless decomposition basically. So in this question, what we basically will do, we will take these dependencies, we will find the candidate key, and then we will divide the table the way they have divided, and then we will see whether the way they have divided it is lossless or not. Okay, so we will start by finding the candidate key here. So MNO, if you can see, we are getting the candidate key as MN plus. Okay, so this is my candidate key. Now if you can see, then here M is breaking the partnership and N is also breaking the partnership. It is not in second normal form. So what we do is, whenever there is partial dependencies, these two are giving, because this is my candidate key and these two are giving the partial dependency, what I will do, I will break them into further tables. Okay, so basically I had the attributes earlier, M, N, O, P, Q, R, S, T. Okay, so M is breaking the partnership, so M plus. So M is giving the partnership as M, P and Q. Okay, it is taking P and Q with it. Okay, next partnership is broken by N plus. So N plus. So N is given as NR. N and R. And R is given as ST. So it is taking ST with it. Now next dependency, N and M and N are breaking relationship. Now candidate key Mn plus. So M, N and O. So I hope you already know how to break a table. Now if you can see here, it is giving the rise to the it is not in third normal form. Why? Because here the dependency R gives ST is making it problem, because it is a non-key. Non-key is giving non-key, so that's why it is not in third normal form. So we will divide the table further. Okay, so what we will do, N plus and R plus. So N is giving NR and R is giving RST. So basically here I have the relation as M derives PQ, okay, with the attributes MPQ. Here NRST, where N derives R with the attributes NR, and R derives ST. So this is my third table, and MNO is my primary table, using which I can refer to those. Now if you can see, it is totally lossless, because how we say a table is in lossless, when a key is the candidate key in one of the table. Here in MNO you can see M is the key in this table, so it is lossless. Here N is the key it is referring here, so it is perfectly lossless. Now RST, it is perfectly lossless because R is the key here, and MN is the main candidate key of our table. So this is my answer, and this is perfectly in lossless property. So let's match it with the given schemas they have divided. So they are saying I am dividing my table. Let me change my marker. So they are saying R1 is MNO. So okay, very good. Now second one they are saying MPQ. Yes, MPQ. Third one they have divided as NRs. Yes, perfect. And the fourth one is RST. Yes, they have divided exactly. It should be divided. So first D1 is lossless. Now let's check for the D2. What they are doing, they have divided as MNOP. Okay, they have divided it here. Then they have derived the table PQ. Now PQ, if you can see, if I make this table as PQ, P or Q, none of them is the key. None of them is key. So as none of them is the key, it is not lossless decomposition. Okay, lossless decomposition means if there is a table, then one of the attributes should be the key of that particular table, but among P and Q none of them is the key, so that's why it is not lossless decomposition. So D is not the answer here. So what they are saying, which of the above decomposition have lossless? So it is D1 only, not D2. Okay, so A is the answer. So we have our next question. So in this they have given us two schedules, and they have given us few transactions inside it, and if you can see there are three transactions in each schedule, and they are talking about whether they are conflict serializable, recoverable or cascadeless. Okay, so with these kind of questions there are so many ways to solve it. Okay, one follows one method and the other follows the other method. Okay, I follow different method. So if the way I solve it is very easy, if you find it useful then you can use this way or you can follow your own way. Okay, so basically first I will solve for S1 and then we will solve for S2. Okay, the process will be lengthy, but when you will have the practice of these kind of question, then you can solve it within a minute. Okay, so I'm doing everything so that you can understand it. If you get it wrong, then you can check where you get it wrong. Okay, so first operation is R3x. It should be R3. R3 means the read operation is performed by the transaction R3. So R3 is performing a read operation on X. After that R1 is performing read operation on X. There is no conflict because read. Then I have read operation by R1 on Z. Then R3 is reading Y. And then W1 read is performed by our operation 1, and then it is performing the commit operation. Very good. Next we have W3Y. It means transaction 3 is performing write operation on Y. Okay, next we have commit. Now it is committed. Did I left anything? R2. I think I missed this one. Okay, so when it was performed after R1Z, then we perform R2Z. Okay, so here basically R2Z, sorry. Okay, so where was I? C3 was committed, then R2Y. Transaction 2 is performing read operation on Y, then write operation on Y, then write operation on Z, and then it is commit. Even before solving the question, we can see one thing, that S1 is recoverable. Recoverable schedules mean we do not commit until the data from we are taking has committed. Okay, and second one is cascadeless. Cascadeless means when let's say I have my data, okay, then I will not perform the read operation from an uncommitted transaction. Okay, I will not do it. Okay, so what I'm saying is, we will see. Okay, So basically, let's see, first of all, it is conflict serializable or not. If you can see, R3 is performing first, so it is not in conflict, not a conflict. But here, yes, it is a conflict, because they are performing read and write operations on the same data. So according to that, T3 must be performed first and then only T1 must be performed. Okay, now next is R1X. Okay, so let's see, is there any conflict with anyone? R1 is it is performing read operation on X. It is not an issue, not an issue. Now R1 is performing read operation on Z. Any problem with that? Yes. Here are chances of read and write, because it is also performing write operation on Z. So T1 must be done before T2. Okay, so next operation is R2Z. Anyone performing R2, but it is read, so not a conflict, not any operation. Any problem we have? No. So it is perfect. Now third, R3Y. Is there any problem with that? R3 on Y. R3 on Y. So yes, there could be a problem because of this. So T3 must be performed first, then T2. So if you can see, there is no cycle, it is broken here, so it is perfectly conflict serializable. Okay, I'm not solving the rest of the question, you can solve it this way. Okay, so for about S1, it is conflict serializable perfectly. Second, it is also recoverable. Why? Because I'm not taking my data from an uncommitted transactions. If you can see, it my transaction T1 is only reading the data Z, and even it is before doing any performing on Z operation, and it is writing on X because it is already reading it. Okay, and no one is performing any writing operation on X, so it is perfect. This one is also taking data from both the committed transactions, and T3 is taking data from already because it is reading the data and it is writing the data, so there is no problem with that. It is not reading from uncommitted transaction, so it is also recoverable, and it is also cascaded because it is not performing any read operation from the uncommitted transaction. Okay, there is, I am not reading data from different. What is that? If I am performing, let's say, write operation on X, and after some time, let's say W3 is also performing, then at that time I have this problem. Okay, or you can also say I am performing any read operation on X, so, and it is uncommitted, so this problem is known as cascading problem. Okay, so do not read from uncommitted transaction. So S1 is conflict serializable, it is recoverable, and it is cascadeless. Okay, it is following all the three properties. Now let's look for the S2. It is looking lengthy, but I am just, for the sake of explaining, I am doing step by step. When you will do on your own, you don't need to write everything. Okay, so let's do for the S2. Here also we have three transactions. So first I'm performing R1Z, then I'm performing R2Z, no problem, they are just reading, and R3Y. Till now no problem. Now R1X, R1 is performing R1X, then R3X, R3X, not a problem. W1X, W1X, then W3Y, then W3Y, then R2Y, R2Y, then W2Y, W2Z. It is basically just like the earlier case, but the only difference is I am performing the commit operations at the end. First C1 is committing, then T1 is committing, then T2, and then T3 is committing. Okay, so let's see what changes does it make. So let's begin from T1. So it is performing read operation on my Z. So is there any problem? Yes, the problem is between these two, because it is performing read and R2 is performing write operation. So it says T1 must be done before the T2. Okay, so let's see. Okay, yes, this was the problem. Now R2 is performing read operation on Z. Is there any problem with that Z on this side? No, so it is perfect, not a problem. Now solved. Now R3Y, is there any problem with that? Is there anyone who is performing write operation on this on Y? Yes, there is a problem. So it means T3 must be performed before T2. Okay, so it is right. Now next is R1X. Is there any problem with that? Is anyone writing on X data? No, it is just reading and it is not doing anything with X, so not a problem. Now T3, it is also performing read operation, but here is the conflict. The conflict is read and write. Okay, it is reading and it is writing later, so it says that T3 must be done before then the T2. So if you will solve this further, then you will get that S2 is conflict serializable. But the problem here is, what I am doing is I am reading the data. What I am doing is I am reading my data over here, okay, and I am reading my data over here, and here I am reading my data. Now I am writing something on X. Now if T1 is performed earlier than T3, then T1 will write some data, and without even doing any checking, R3 is performing read operation on X. Again, if you will see that here it is reading in this, I have problem. Now in this, what happening is T3 is writing on Y, and T2, what it is doing, it is from uncommitted. T3 is still in uncommitted state and it is taking data from T3. So that is why it is causing the problem of cascading, and also it is unrecoverable. Why? Because I am taking my data from the uncommitted transaction. Also from uncommitted transaction I am reading directly my data. I am performing read operation directly, and we are not even waiting for its commit operation. So all the problem is being created because we are performing commit operations on the end. Okay, so that's why C2 is not recoverable and not cascadeless. Okay, so let's see which option matches. B says it is conflict serializable, recover and cascadeless. Okay, so B is the right answer here. Why? Because only B option says S1 is conflict serializable, recoverable and cascadeless, while S2 is conflict serializable, neither recoverable nor cascadeless. Okay, I hope you understood the question. So we have our next SQL question. In this, what they have given is, they have given a table with name student, and in this the attributes are first name, last name and the city. So they are saying the number of tuples in the result table if we execute the following SQL query is, assume that between operator includes both the test cases. Okay, we know that already. In the between operator, both the boundary values is included. Like if I say age between 30 to 40, it means age including 30 and 40. But if when I say not between, then boundaries are not included. When I say not between 30 and 40, then it means 31 to 39. Okay, at that time boundaries are not included. Okay, so that is a different case. So they're saying select star from student. So star means we have to display all the information where first name not between Harish and Manish. Okay, not between Harish and Manish. So when between operator is applied with the non-numeric data, then what we do is we take the ASCII values on it. Okay, so basically what we will do, I will take the H and I will take the M. We can take the whole name, but no need. Okay, so what we will do, it will be like H I J K L and then I have M here. Okay, so they are saying that the select star where first name not between. So first name should not be between this. So here we do not care about the boundary values because it is the non-numeric data. In numeric data we include the boundaries in between, and in not between we do not include the boundaries. But here the name is total Harish and the name is here Manish. Okay, we are not just talking about one value, it is the whole value. So H and M will be included. So no need to get confused. So basically when I use the between operator with non-numerics, what we will do, we will project from H to M and all the alphabets in between them, okay, and they should not be included. So Shrikant is in between, S is between them, no, so Shrikant will be here, answer. Lalit, L, so Lalit will not be printed. Manish, it will not be printed. Prashant is not between them, so Prashant will be printed. And Harish will not be printed, so answer is 2 here, okay. So we have our next question. In this they are saying the highest normal form achieved by the relation R with attributes A, B, C, D, E, F with the functional dependencies, and they have given us few dependencies, okay. So they are talking which of the what is the highest normal form this table is achieving, okay. So what is the first step in doing these question? We will find the candidate key first, okay. So if you can see, the candidate key is A, B plus here, because A, B is given, and then A is giving C, D, and then B is giving E, and E is giving F. So AB is my candidate key. Now AB is my candidate key, but if you can see in the first functional dependency itself, it is showing the partial dependency in A derives CD, okay, it is giving partial dependency. In the B derives itself, it is giving the partial dependency. So it is not in second normal form. So if it is not in second normal form, it is not in third normal form, and BCNF as well. So what is the lowest normal form it is achieving? It is first normal form, clearly. So we have our next question. So in this they have given us 2 schedules, and they have given us few transactions inside it, and if you can see, there are 3 transactions in each schedule, and they are talking about whether they are conflict serializable, recoverable, or cascadeless, okay. So with these kind of questions, there are so many ways to solve it, okay. One follows one method and the other follows the other method, okay. I follow different method. So if the way I solve it is very easy, if you find it useful, then you can use this way, or you can follow your own way, okay. So basically first I will solve for S1 and then we will solve for S2, okay. The process will be lengthy, but if when you will have the practice of these kind of question, then you can solve it in within a minute, okay. So I'm doing everything so that you can understand it. If you get it wrong, then you can check where you get it wrong, okay. So first operation is R3x. It should be R3. R3 means the read operation is performed by the transaction R3. So R3 is performing a read operation on X. After that R1 is performing read operation on X. There is no conflict because read. Then I have read operation by R1 on Z. Then R3 is reading Y. And then W1 read is performed by our operation 1, and then it is performing the commit operation. Very good. Next we have W3Y. It means transaction 3 is performing write operation on Y. Okay. Next we have commit. Now it is committed. Did I left anything? R2. I think I missed this one, okay. So when it was performed after R1Z, then we perform R2Z, okay. So here basically R2Z, sorry, okay. So where was I? C3 was committed, then R2Y. Transaction 2 is performing read operation on Y, then write operation on Y, then write operation on Z, and then it is commit. Even before solving the question, we can see one thing, that S1 is recoverable. Recoverable schedules mean we do not commit until the data from we are taking has committed, okay. And second one is cascadeless. Cascadeless means when let's say I have my data, okay, then I will not perform the read operation from an uncommitted transaction. Okay, I will not do it. Okay, so what I'm saying is, we will see. Okay, so basically let's see first of all it is conflict serializable or not. If you can see, R3 is performing first, so it is not in conflict, not a conflict. But here, yes, it is a conflict, because they are performing read and write operations on the same data. So according to that, T3 must be performed first and then only T1 must be performed. Okay, now next is R1X. Okay, so let's see, is there any conflict with anyone? R1 is it is performing read operation on X. It is not an issue, not an issue. Now R1 is performing read operation on Z. Any problem with that? Yes. Here are chances of read and write, because it is also performing write operation on Z. So T1 must be done before T2. Okay, so next operation is R2Z. Anyone performing R2, but it is read, so not a conflict, not any operation. Any problem we have? No. So it is perfect. Now third, R3Y. Is there any problem with that? R3 on Y. R3 on Y. So yes, there could be a problem because of this. So T3 must be performed first, then T2. So if you can see, there is no cycle, it is broken here, so it is perfectly conflict serializable. Okay, I'm not solving the rest of the question, you can solve it this way. Okay, so for about S1, it is conflict serializable perfectly. Second, it is also recoverable. Why? Because I'm not taking my data from an uncommitted transactions. If you can see, it my transaction T1 is only reading the data Z, and even it is before doing any performing on Z operation, and it is writing on X because it is already reading it. Okay, and no one is performing any writing operation on X, so it is perfect. This one is also taking data from both the committed transactions, and T3 is taking data from already because it is reading the data and it is writing the data, so there is no problem with that. It is not reading from uncommitted transaction, so it is also recoverable, and it is also cascaded, because it is not performing any read operation from the uncommitted transaction. Okay, there is, I am not reading data from different. What is that? If I am performing, let's say, write operation on X, and after some time, let's say W3 is also performing, then at that time I have this problem. Okay, or you can also say I am performing any read operation on X, so, and it is uncommitted, so this problem is known as cascading problem. Okay, so do not read from uncommitted transaction. So S1 is conflict serializable, it is recoverable, and it is cascadeless. Okay, it is following all the three properties. Now let's look for the S2. It is looking lengthy, but I am just, for the sake of explaining, I am doing step by step. When you will do on your own, you don't need to write everything. Okay, so let's do for the S2. Here also we have three transactions. So first I'm performing R1Z, then I'm performing R2Z, no problem, they are just reading, and R3Y. Till now no problem. Now R1X, R1 is performing R1X, then R3X, R3X, not a problem. W1X, W1X, then W3Y, then W3Y, then R2Y, R2Y, then W2Y, W2Z. It is basically just like the earlier case, but the only difference is I am performing the commit operations at the end. First C1 is committing, then T1 is committing, then T2, and then T3 is committing. Okay, So let's see what changes does it make. So let's begin from T1. So it is performing read operation on my Z. So is there any problem? Yes, the problem is between these two, because it is performing read and R2 is performing write operation. So it says T1 must be done before the T2. Okay, so let's see. Okay, yes, this was the problem. Now R2 is performing read operation on Z. Is there any problem with that Z on this side? No, so it is perfect, not a problem. Now solved. Now R3Y, is there any problem with that? Is there anyone who is performing write operation on this on Y? Yes, there is a problem. So it means T3 must be performed before T2. Okay, so it is right. Now next is R1X. Is there any problem with that? Is anyone writing on X data? No, it is just reading and it is not doing anything with X, so not a problem. Now T3, it is also performing read operation, but here is the conflict. The conflict is read and write. Okay, it is reading and it is writing later. So it says that T3 must be done before then the T2. So if you will solve this further, then you will get that S2 is conflict serializable. But the problem here is, what I am doing is I am reading the data. What I am doing is I am reading my data over here, okay, and I am reading my data over here, and here I am reading my data. Now I am writing something on X. Now if T1 is performed earlier than T3, then T1 will write some data, and without even doing any checking, R3 is performing read operation on X. Again, if you will see that here it is reading in this, I have problem. Now in this, what happening is T3 is writing on Y, and T2, what it is doing, it is from uncommitted. T3 is still in uncommitted state and it is taking data from T3. So that is why it is causing the problem of cascading, and also it is unrecoverable. Why? Because I am taking my data from the uncommitted transaction. Also from uncommitted transaction I am reading directly my data. I am performing read operation directly, and we are not even waiting for its commit operation. So all the problem is being created because we are performing commit operations on the end. Okay, so that's why C2 is not recoverable and not cascadeless. Okay, so let's see which option matches. B says it is conflict serializable, recover and cascadeless. Okay, so B is the right answer here. Why? Because only B option says S1 is conflict serializable, recoverable and cascadeless, while S2 is conflict serializable, neither recoverable nor cascadeless. Okay, I hope you understood the question. So next we have our question in which they have given us 4 transactions. They are saying consider the following schedules consisting of 4 transactions. Okay, so we have to tell whether it is conflict serializable, and then they are saying it is not conflict serializable but view serializable with the sequence, and it is not but view serializable with the sequence, and it is neither. So basically they are talking about the conflict serializable and view serializable, and if it is not conflict serializable then it is view serializable and true sequences are given. Okay, so let's solve the question. So what we will do, we will pick the transactions one by one and we will try to make the graph, and if there is any cycle then it will not be conflict serializable, and then we will check for the view serializable. Okay, so let's first check for the conflict serializable, because we know the property, if something is conflict serializable then it is definitely view serializable. But okay, but if it is not conflict serializable then there are chances that it will be view serializable. Okay, so here T1 is performing read operation on X. Can it be, is there any conflict? Yes, there is a conflict of write operation on X, because it is performing read operation on X and T2 is performing write operation on X. So there is a conflict. How can we resolve it? T1 must be done before then T2. Okay, now read operation on Y, is there any problem with that? Yes, there is a problem because of this. T4 is performing write operation on Y, so T1 must be done before T4. Okay, Now it is done. Now let's see this next one. So it is saying read operation on X and it is doing read operation on X. It means there is a conflict. How it can be resolved? T2 must be done before T4. Okay. Now next is read operation on Z. Is there any problem with that? Yes. Here read and write operation on Z. So it means T2 must be done before T3. So let's make T3 here. According to this, T3 must be done, T2 must be done before T3. Okay, now T2 is now resolved. Now let's look at the fourth one. It is performing write operation on Y. Is there any conflict with this? Yes, there is conflict with T4 and T1. According to this, T4 must be done before T1. So here is the problem. We have got a cycle. Okay, but let's proceed. Next it is saying read operation on X. Is there any problem with this? No, it is just performing read operation, so not an issue. Next is read operation, write operation on Z. Is there any problem with anyone? Yes, there is, and the problem is this one. So according to this, it is saying T3 must be performed before then T2. T3 must be performed before the T2. So here again the cycle. So clearly it is not conflict serializable. Okay, now let's look for the view serializable. So basically you can see there are two blind write. Blind write is when without any reading or any seeing the committed uncommitted, we write our data directly. So there are two blind writes. Fine, but if you can see how we solve the view serializable, here the problem is with the Y data. It is reading Y data and it is writing Y data. It means T1 must be performed first, but here T1 is depending upon the T4, so that's why it is not view serializable. Okay, here one more time, here blind write is performed on Y. Okay, it means the T1 transaction must be done before. If there would have been no this edge no present, then it would be perfect, but here T1 is actually depending on T4, so that's why it cannot be a blind write. Now next problem is with the Z operation. It is performing Z operation. It means T2 must be performed at the end. So basically T2 must be performed at the end, but T2 is giving value to T4, so that's why it is also causing the problem. So it is clearly not view serializable. So for 26th question, it is not conflict serializable nor view serializable. So answer is D here clearly. So to solve this question, there are many ways you can solve it. So different people follow different method. So you can solve it using graph method, or you can directly look into this. If there are blind writes, then you check for the condition that it must perform the operation in the end. If it is reading first, then it must read first in all, and if it is writing last, then it must write or last in after all the transaction. And due to the blind write, there was a chances of view serializable, but due to these 2 R's, it is not view serializable. So you can solve this question in many ways. So we have our next question from SQL. They are saying the aggregate function that does not ignore null values in its input collection is average, sum, max, or none of this. Okay, so basically they are talking about the aggregate functions. Okay, so what I will do, I'll make a table which will be the collection of values and null values, and we will see how these values perform with the null values. Okay, so let's say I have a table B which has some attribute. Let's say with A, it has values 1 and let's say null, and let's say one more null is here. I'm giving the worst case. Okay, 2 and 3. So the first is average. So when I find the average, so let's say it's AVG of B. Okay, basically we write for the A. Okay, we talk about the attributes values. So what is the average of A? So what it will do, it will ignore the null values completely and it will calculate the average with the rest value. So how to calculate the average? 1 plus 2 plus 3 divided by how many values? 1, 2 and 3. Okay, so answer will be 2 here. So basically average, what it does is it ignores the null value. Next we have is sum. Sum, what it will do, it will ignore again the null values and calculate the sum with rest of the values present. So sum also ignores the null value. Next we have max. Max will return 3. It also ignores the null value. So basically our answer is none of these. Then is there any aggregate function which do not ignore the null values? Yes, there is. It is count star and count. Okay, count basically returns 0 for null values, and when I say count star, then it will return 1, 2, 3, 4, 5 because there are 5 values present. So it is count star and count that do not ignore the null values. So it is not mentioned here. So answer is none of these here. So here we have our next question, which says which of the following statement is false? False statement regarding the two-phase locking protocol. So they are saying it ensures the complex serializability. B option says transactions can be serialized in the order of their lock points. C option says doesn't ensure freedom from deadlock, and the D option says cascading rollback is not possible. Okay, so basically you have to remember 2 points about the two-phase locking protocol. The first one is first we have growing phase. In the growing phase we acquire the locks, and the next we have shrinking phase. In shrinking phase what we do is we release the locks. Okay, so the first point says don't release the locks until you get all the locks you need. Don't release the locks until you get all the locks. Until you get all locks. Okay, and the second point says, and once you start releasing the locks, then you don't get the locks. Once you release, can't acquire locks. Okay, so basically in two-phase locking protocol we have growing phase and shrinking phase. In growing phase you acquire all the locks, and in the shrinking phase you release the locks. And once you start releasing the locks, then you can only release the locks, you cannot acquire them. Okay, and on the basis of that we get the lock points. So basically if there are suppose T1, T2 and T3 and there are shared data exclusive locks for A, B and C, exclusive and shared locks. Exclusive locks means you also wants to perform the write operation, so at that time you basically acquire the exclusive locks. For the read operation you acquire the shared lock. Okay, so that's a different point. So let's say T1 gets all the locks it's required on, let's say it want data A and B, so it get acquired lock for A and B, so T1 will be performed. After that let's say T2 wants to perform and it needs A and C, then after the release of T1, T2 will get the chance and then T3 will be get chance. So basically that's why due to the proper ordering they will be perfectly conflict serializable. So A option is right here. Okay, and the second option says transaction can be serialized in order of their locking points. Yes, this is what I have just explained to you. On the basis of the lock points they are perfectly ordered, and that is why they are perfectly serializable without any conflict serializable. So the C option says it doesn't ensure freedom from deadlock. So this is also right. Why? Because let's say I have two transactions T1 and T2. T1, what it does is it acquired an exclusive lock on A. At the same time, let's say, because we talk about the acquiring the locks on the same data, we do not talk about the acquiring on different data. T2 can acquire lock on data B. It definitely, if let's say transaction T2 tries to acquire exclusive lock on A, then it will be blocked. obviously it cannot acquire lock on A because T1 has already acquired it, but it can acquire on B, so it is fine. Now let's say T1 wants exclusive lock on B, but it cannot get it, so it is also blocked. It is blocked here. And now let's say for the completion of T2, it realize it also needs the data on the lock on A. So basically T1 is waiting for the lock B and T2 is waiting for the lock A here. So that's why it is the kind of deadlock situation. So that is why it do not ensure the freedom from the deadlock. Okay, so C is also right option. D is the right answer here because we have to pick out the false one. Yes, cascading rollback is not possible in this because we are ensuring through the growing and shrinking phase. Okay, so we have our next question, which says which of the following is true. So the first statement says if a schedule is conflict serializable, then the schedule will also be view serializable. And the next one says if a schedule is view serializable, then the schedule will also be conflict serializable. Both are true or none of these. Okay, so always remember, if a schedule, let's say serializable, so there are two cases. If it is conflict serializable and if it is not conflict serializable. Okay, if it is conflict serializable, then it will also be view serializable as well, without any doubt. Basically it looks like this: conflict serializable, view serializable, sorry, and then all possible schedules, all schedules. Okay, so you can see from this diagram that if schedule is conflict serializable, then obviously it will be view serializable as well, but there will be some cases where it will be view serializable but not conflict serializable. So how can we categorize it? That if there is blind write, then there is a chance that it is view serializable as well. But if there is no blind write, then blindly it is not view serializable. Okay, so from this diagram you can say A is the right option here. If a schedule is conflict serializable, then the schedule will also be view serializable. If a schedule is view serializable, then the schedule will also be conflict serializable. B is wrong, and so do these two other options. So A is the answer here. So in our next question, they are saying find the highest form of relation R ABCD with FDs. So basically they are talking about what is the highest normal form our relation is accepting or acquiring. Okay, so what is the first step in doing this kind of question? We find the candidate key. Okay, so let's find out. So let's see. A plus, yes, A is deriving C, AC is deriving B, D. So yes, A is our candidate key and it is our only candidate key because it cannot be derived by anyone else. So A should be here. So if we include A, it will become a super key, not a candidate key. So A plus A is our candidate key. Okay. So A is our only candidate key, and if you can see in the relation, okay, it is following the 1NF property because there are no multi-valued and composite keys. It is also following the second normal form. Why? Because A is all alone here. There is no chance of having the partial dependency. So it is also in 2 normal form. For 3 normal form, what is the property? Non-key attribute should not give a non-key attribute. But clearly we can see here B is giving C. Okay, so that is why this is non-key giving non-key. B is non-key, C is non-key, so it is not following the third normal form. So highest normal form which our table is giving is second normal form, so B is the answer here. So next we have question. In this they are saying, in the basic timestamp ordering scheme, say a transaction T issues write queue operation, then which of the following is true? And by TS they means the timestamp. So first option is saying timestamp of T is less than the read timestamp of Q, then write is rejected and T is rolled back. B option says if timestamp of T is less than the write of timestamp of Q, then write is rejected and T is rolled back. Both A and B and none of these. Okay, so basically in the congruency manager we have this timestamp ordering protocol denoted by TO. Okay, in this basically what we do is we assign the we assign some timestamps to the transactions when they first enter into the system, and on the basis of that we provide them some ordering, and then they are executed on the basis of their orders. Basically what happens is, let's say there was a old transaction in some I transaction already in my system and some new J transaction come. So obviously timestamp of I will be lesser than timestamp of J because it is the older. So that's why I will be this I transaction will be processed earlier than J. So basically what happens is we are giving them the order. Okay, so for the proper order and the serializable we are doing this. It is perfect. Now what happens is, within the transaction, to avoid any conflicting read write operation, we provide even the ordering in between them two. Okay, for conflicting read write operations. Okay, and what we do is it compares. It is very important point because this is the question we are going to solve. It compare T. T means timestamp of our main transaction T with the read timestamp of any, let's say here the data we are performing is Q, and with the write timestamp of Q. Okay, so basically what we do is we give the ordering to our transactions, okay, first, and the second, to avoid among them for conflicting read write operation, it compares the timestamp of main T with the read and write operation on that particular data. So to ensure that there are basically two conditions which are given when it is performing. So I am talking about here, they are talking about issuing. T issues the write queue. For read queue there will be different set of operations and different set of limitation. We are here talking about the issues with the write queue. Okay, it means writing on item X. So under this we have to follow two conditions. The first condition is, if read timestamp on any data here, let's say Q, if it is greater than the timestamp of our T, or if write timestamp of our Q is greater than the timestamp of T. In both the cases we are going to abort, or you can say roll back, our transaction. Okay, so this is easy. We just have to compare the timestamp of our transactions with its read timestamp of on a particular data, and it is done for to avoid the read write conflict. So basically if there is a conflict between the transactions, we assign them some timestamps. So this is how they are solved, but to avoid the read write conflicts, this is how we do. Okay, so let's read out the options. So first option says, if T timestamp of T is less than read timestamp of Q, then write is rejected and T is rolled back. Yes. Also, if timestamp of t is less than the right timestamp of q, then the right is rejected and t is rolled back. So basically both of the options are right here. So C is the right answer here. You can find many references for this question in Wikipedia and all other if you have not understood here. So basically it is a easy question. They are basically talking about the timestamp ordering scheme. First we divide the transactions on the basis of their timestamp when they are enter into the system, and next when there is a read write operation and we do not want any conflicts of the read write operation, then what we do is we compare the timestamp of our t with the read and write timestamp of on the particular data here like q, then the two conditions are given. Here I have explained you only for the write queue. For the read queue there will be different set of restrictions. Okay, I hope you understood. So in the next question they are saying find out the set of FDs for which the relation R ABCDE with attributes is in 3NF but not in BCNF. Okay, so basically there is a slight difference between 3NF and BCNF. So let's say if I have a dependency like x tends to y, then in 3NF it will be in 3NF in two cases. If x is super key, or you can say key, and y is a prime attribute. In either of the cases the relation will be in 3NF. Now for BCNF, here the only condition is x should be a super key. We do not care about this side, but this side should be super key to be a BCNF. Okay, so what we will do, we will solve these four options one by one, and we will have to actually check that it should be in 3NF but not in BCNF. Okay, so for the first one it is given as AB gives CD, AC derives BED. So how do we solve these kind of question? We try to find out the candidate keys and then we see if any of the relation is breaking these kind of rules, and if it is properly satisfying then the relation will be in 3NF or BCNF. Okay, so for this relation if you try to find out the candidate keys, it will be AB, CD, BD and AC. Now this is right, this is also right, AB and AC are candidate key, but if you look at this one here, A is prime attribute, D is not a prime attribute, it's a non-key, but it is a prime attribute, so it is satisfying this property that it is in 3NF, and it is not in BCNF. Why? Because D is not a super key. So this is the answer here. A is the answer. We have to find out the relation which is in 3NF. It is 3NF because A is a prime attribute, it is following the second property, so it is in 3NF, but not in BCNF because D is not a super key. So A is the answer. Now let's solve all the rest of the options. So for the second option it is AE derives CD and D derives B. Now you can clearly see that AE is the candidate key over here. Now this is right because A is the candidate key, but if you look at this one, D is non-key attribute and B is not a prime attribute, it is also a non-key attribute. So non-key is giving a non-key attribute, so it is not in 3NF. It is not in 3NF, so obviously it will not be in BCNF. It is not even in 3NF and also in BCNF. Okay, so let's solve the next question. So for the third option, I think it is I hope it is visible, so let's change the marker. So for the third one it is AC derives ED and A derives BC. As you can see, A is our candidate key. So if A is our candidate key, what is AC? It is our super key, and this is also our super key or candidate key. So this is a super key giving non-key attribute, super key giving non-attribute. It is perfectly following the BCNF property. It is in BCNF. So if it is in BCNF, obviously it is also in 3NF. But this is not the answer because we have to tell which is in 3NF but not in BCNF. Okay, now let's solve the fourth option here. So in the fourth option it is given as AB derives CD For these kind of question, actually it is very easy to solve, but the thing is you have to read the question very, very carefully. During the exam sometimes students skip this part, is in 3NF but not in BCNF, so you have to be very careful. Okay, there are 4 types of answers that we will be getting. So for this relation, if you try to find out the candidate keys, those will be AB and my AC. A is not our candidate key, you can find out. It is clearly shown. A is giving only BD, and after that I'm getting only this part. So that is why A is not our candidate key. So AB is our candidate key. This is satisfying. Now this one, if you look here, okay, so what is our B? B is our prime attribute, but it is not a super key, and even it is showing the partial dependency, because AB is our candidate key and B is showing partial dependency. It is not even in 2NF. Also, if you don't catch this, still if you can see, E is not my prime attribute. If E is not my prime attribute, so definitely it is not in 3NF, and if it is not in 3NF, it is also not in BCNF. So clearly our answer is 1 here. I hope you understood the question. So we have our next question. In this they are saying find out the minimal cover for the FD, and the set is given over the relation R ABCD. So basically what we have to do, we have to find the minimal cover of this. Now what happens is, in this we have to do 2 things. Okay, so let's say first case is A plus A derives BC, and the other cases, let's say it is just hypothetical, okay, not related with the question, I'm just giving you the concept. So this is the first step and this is the second step. So whenever we have this kind of joined attributes combined, then what we do in compound, we will try to break them. Okay, A derives B and then A derives C, and we will see if let's say if one of them can be derived by anyone else, then we will remove it. Let's say B is also deriving C somewhere in this question. Okay, then you can see that A is deriving B and A is also deriving C and B is deriving C. Then obviously this is you can say a duplicate. Okay, because A is deriving B and B is also deriving C, then I don't need to write this one. Okay, so in this case we will try to remove these kind of cases. Now look at this side, this is an important case. Whenever this kind of dependency is given, what we will do, we will try to remove any one of them. Now how to remove? We will try to find out the A closure and B closure. If A closure can derive B and if B closure can derive A, then we will remove any one of them. What I want to say, if A closure is B, then what we will do, we will totally remove B from here and it will be only A derives C. Okay, so I hope you got my point. What we will do, we will try to solve the question and then all these points will again come up, because you can see these kind of dependencies are also here. Okay, do make a good note of this question. This is a very good question and they do ask lot of questions from these minimal cover type question. Okay, so let me rewrite the dependencies. A derives BC, B derives C. If you can see, we will break it. Okay, and A derives B. We don't need to touch these kind of dependencies, all right? And AB derives C and AC derives D. Okay, so first what kind of case has been taken? This kind. Okay, so we will write A derives B and A derives C. If you can see, A derives B is already here. Okay, so we don't need to write it. Okay, now if you can see, for this A derives C, A is deriving B here and B can derive C. Okay, and this is already given, so we don't need to write this one also. Okay, so in A derived BC is broken into A derived B, A derived C. This is already given, so we will remove it. And A derived C can be derived from these two, and these are already given and we don't need to remove them. Okay, so we can totally eliminate this dependency. Okay, so let me rub this one. So basically we don't need to write this one at all. Okay, so let's solve the next one. So this is perfect, minimal already, this one is already minimal, so let's solve this one. AB derives C. So I have told you how to solve this one. So let's find the A closure. A closure, when A closure is found, A closure gives B. Okay, so I can remove my B from here. Okay, because A closure, A plus can give my B. Okay, so now what is left? It is left as A derive C, and we have already seen we don't need to write A derive C. Why? Because A is deriving B and B deriving C, so we don't need to write it. So basically you can say that we don't need to write this one as well. Okay, I hope you get my point. So let's solve this one. AC derives D. Now let's try to find out the A closure. A closure is giving A, B, and B can give C, and A and C can give D. So it means A closure, basically A closure can give C, right? So I can remove my C from here. So I can just write A derive D here, and it cannot be derived by anyone else, so this is also right here. Okay, so what are the dependencies we need to have? Function dependency: B derives C, A derives B, and A derives D. We don't need C here. Why? Because C can be derived from A, because A derives B and B derives C, so I don't need C here. Okay, so just A derives D, so it matches with the B's option, right? A derives B, B derives C, and A derives D. So B is the right answer here. I hope you understood the question. So we have our next question. In this they are saying consider the relation R, and they have given us 10 attributes with the following set of functional dependencies. So they have given us few FDs. They are saying determine the highest normal form of R and the total number of extraneous attributes in F. So I'll tell you what are extraneous attributes. Okay, so first let's see what is the highest form achieved by this relation. Okay, so how we do that? First we have to find out the candidate key. Okay, so we will find out the candidate key. So is it A1, A2? Let's find out the closure of A1, A2, because A1 is deriving, it will derive A1, A2. So you can do it on your own. I don't need to tell how to find the candidate key. And A1, A2 combined will give A3, and then A2 can give A6, and A6 can give A7, A8, and A4 can give A9 and A10. So yes, these are my, and this is my candidate key. What? A1 and A2 combined are my candidate key. Now if you look at the FDs, this is giving a partial dependency, because our candidate key is A1, A2, and A1 is deriving A4 and A5, and again A2 is also breaking the partnership. So because of these are given partial dependency, so it is not in 2NF. So it is the, what is the normal form they are achieving? It is the one normal form. Okay, so it is in one normal form. Now next is, what is the total number of extraneous attribute? Now what are extraneous attributes? Let's say I have a function dependency given here, AB derives, let's say, C. Okay, now it works only in these kind of cases. Okay, so I'll tell you what these are. So let me erase this, otherwise you'll get confused. Okay, so the answer for first one is 1NF. Now let's say it is derived as AB derives C. So I can, for the extraneous attribute we need these kind of cases, okay, where two values are derived like this. Okay, so let's say AB derives C. So this is just hypothetical. Now if A closure can give B, then obviously I don't need B here. Okay, so in that case I can write just A derives C, and A closure can give C directly. Okay, I don't need B in that case. If A is giving B and AB is giving, let's see, this is the kind of case, okay, I'm talking about. If A is deriving B already, A closure is already deriving my B, then I don't need B here. Or the reverse case is also true. B is deriving A, then in that case I can remove A. So in that case B is my extraneous attribute. Okay, now in this case this work only in these kind of cases. Now A1 closure is not deriving A2, nor A2 closure is deriving A1. You can check by A6 and all these things. So I cannot remove any of them. So A1 and A2 combined both are giving A3 only, okay, and no one can derive it, so we cannot break them. Okay, we have solved this kind of question in partial dependencies also. So in that case we have zero extraneous attribute. Why? Because I cannot remove A1 and A2 from each other. Okay, so answer is A here, 1 NF and 0 extra NS attributes. So we have our next question. In this they are saying consider the relation A, J, KL, B and C having the tuples 100, 2000 and 55 respectively. Estimate the number of tuples on A join B join C. Okay, so these are the joins conditions. Okay, so basically they will be joined on the basis of the common attributes they will have. Okay, now in the A there are 100 tuples, on B we have how many? 2000 tuples, and in C we have 55 tuples. Then estimate the number of tuples. Okay, now let's say I want to join A and B. It is very easy actually, you just have to understand the concept. A has 100 attributes, B has 2000 attributes. Now if I want to join A and B, then how many values that A and B can match? Maximum values, only 100. All hundreds here matching with all 100 here. So what will be the output of this condition? Maximum, if I am talking about, it will be 100. Okay, I hope you're getting my point. Here are 100 attributes, here are 2000 attributes. I want to join both of them. Then how many tuples will be the same? Maximum, it will be 100 only. Okay, because 100 from here matching with 100 from here. Okay, now I have got 100 here. Now let's compare these two. Now how many tuples maximum there can be the matching in both the tables? 55. In these two, maximum only 55. All 55 here matching with 55 here. So what will be the answer? Clearly here B is the answer. Okay, so next we have our question. In this they are saying maximum cardinality of natural join over two relations Mn and R. Okay, so if you know, in natural join what happens is, when I want to join two tables, let's say here M and N are given, let's say it has attribute A and C, and let's say N has attribute A and D, then when I want to join two tables, it will be joined on the basis of name of the attribute. They must be same. Okay, so this is the first case, the attribute names must be matching, then only I can do the natural join. But the second case is, if attributes name do not match, then we apply cross product. Okay, do remember this point. Okay, it is very important. They do ask many questions converting in one way or another. Always remember, when the name attributes are not matching in natural join, then we will apply the cross product. And in the cross product, what happens is, how we do the cross product, all the attributes from here will be joined with all the attributes here. So it is basically M cross N. All the attributes will be present. So answer is clearly C here.